Alright, I want to do a basic trig review from your Algebra 2 course or trig or math analysis course, whatever you took, that will hopefully, if you're forgetting some of the things, hopefully give you the fundamentals you need to know for calculus with trig stuff. So, basically what you need to know in trig is how to come up with basic angles of sine, cosine, tangent, secant, so forth functions. Mostly you'll see sine, cosine, tangent, but you could see other ones as well. So when I say basic angles would include 0, pi over 2, 2 pi, 3 pi over 2, pi over 3, pi over 6, pi over 4, and any variable of that too, like it could be 3 pi over 4 or anything like that. But they usually keep it fairly basic when you're talking about the AP test. So first thing I want to make sure we all are clear about is the unit circle. I always use this on my test, and that clearly does not look like a unit circle because it's supposed to have a radius of 1, and obviously it doesn't look like that. But that's not too important as long as you know it's supposed to have a radius of 1 everywhere. So this point right here on the unit circle would be the point 1, 0. This point right here would be the point 0, 1. We'd have negative 1, 0, and 0, negative 1. And I hope that that's big enough for you to see that. But, and then the angles on this angle would be 0, I'll write bigger now, pi over 2, pi, 3 pi over 2, and so forth. This could be other angles, like for instance, 0 would then be 2 pi, and you could add from there, or you could go backwards, and this angle would be negative pi over 2. So, we have to kind of be able to work with those angles as well. This works really well if you want to know the sine, cosine, tangent of any of these angles right here. So, for instance, say I wanted to know what is the sine of pi, for instance. Okay, I'm on a test and you know the sine of pi. What you do, you look to this chart, and the sine is the y value at that point, or at that angle. So here's this angle pi, so that means we're looking at this point, the y value is 0. So again, the x value here is cosine, the y value is sine on this chart. So I know sine of pi, that's 0. Say I'm looking for cosine of 0. Well, here's the angle 0. Cosine is the x-coordinate. That's 1. Say I'm looking for sine of negative pi over 2. Negative pi over 2, I'd come down for right here. It's the y-coordinate. It's negative 1. So all of those angles we should be able to come up with real quick. And again, I always like to, on a test, just put this up in the corner as soon as I got it. So even though maybe I knew these angles, just on a test, if you're going quickly, you can just refer to it so you aren't going to make a mistake. So all of those types of angles you need to know. Okay? But we also need to know other angles as well. And we're always working with radians, never degrees. So we do have to be comfortable with radians. So for instance, we need to know what is sine of pi over 3. Okay, that's definitely something we need to remember. Now, I'm not a big memorizer. I really don't have this memorized, but I do know something about it. I know that pi over 3 is part of a special triangle. All right, and if you're talking in degrees, that's a 30, 60, 90. If you're talking in radians, it's pi over 3, pi over 6, and usually we still call it 90, but pi over 2. So I'm going to draw that triangle out. It's a right triangle, and these, I'm not drawing this to scale at all, but I know on this triangle that one of the angles, of course, is pi over 3. It means right there. And the other one is pi over 6. And I have memorized something else. I know what the sides are on this triangle. Now, I don't always know where to put them right away. I know that the sides on the triangle are 1, 2, and square root of 3. So I kind of have to think in my mind, okay, which number do I place where? And this is how I think about it. Well, the hypotenuse, the side opposite the right angle, is the biggest side. So what's the biggest number out of 1, 2, and square root of 3? 2. So that's going to go there. So that one's taken care of. And then I have to think, okay, well, which of these angles are bigger? And pi over 3 is a larger angle than pi over 6. You have to think, right? This is, if you divide something by 3, that's a lot, it's going to be bigger than if you divide it into 6 pieces, okay? So this angle is larger, so the side opposite it will be larger than the other side. So square root of 3 is the next largest between those two numbers, and 1 is the smallest, it's the only one left. So I can just look for this, and I know that sine, I do have to memorize that, is opposite over hypotenuse. So I look at sine of pi over 3 as square root of 3 over 2. And, so if I had, like, what is tangent of pi over 6, for instance, I do need to know that tangent is opposite over adjacent. So tangent of pi over 6 would be 1 over square root of 3. Okay? So knowing how to come up with that triangle is super duper important. We have to know that. And also, for instance, we do need to know something like this, like cosecant of, let's say, pi over 3. We do need to know how to work with cosecant. And what we need to know is that cosecant is equal to 1 over sine. So this really is the same thing as 1 over sine of pi over 3. Okay? Which, notice, we've already found up here, but if you hadn't, you could just look for the triangle to find it. So this is just 1 over square root of 3 over 2. So then you could just simplify that. If you divide 1 divided by square root of 3 over 2, that's the same thing as doing 1 times 2 over square root of 3. So that just simplifies to 2 over square root of 3. Okay. So very, very important to know how to come up with that triangle and how to deal with any of these angles dealing with pi over 3 or pi over 6. All right. Another one that's important is pi over 4. Okay. So pi over 4, again, is part of a special triangle. In degrees, it's 45, 45, 90. But in radians, it's pi over 4, 90, or pi over 2. All right, and the sides on this triangle here are going to be 1 and square root of 2. So let's see here. I've only put in 2 because 2 of the sides are going to be the same. But between those two numbers, square root of 2 is clearly larger, so that's going to have to be the hypotenuse. And, both of these angles are the same, so the side opposite both of them will be the same too. It'll be 1. Okay? Cosine of pi over 4, so I can look for either of those angles, but cosine is adjacent over hypotenuse. So let's say if I look at this angle, the adjacent side is this side. The hypotenuse is square root of 2, so it's 1 over square root of 2. And if you rationalize that, it's square root of 2 over 2. You don't have to, but just to know that it's the same thing is important. Okay? Let's look at another one. How about, let's say we have secant of pi over 4. So secant is another one you need to know. So secant is 1 over cosine. So this is the same thing as saying 1 over cosine of pi over 4. So we just found out that cosine of pi over 4 is this value, 1 over square root of 2. So instead of dividing by 1 over square root of 2, you could multiply by square root of 2 over 1. So this is just square root of 2. Okay, secant of pi over 4 is just square root of 2. Okay, last thing I want to mention here is you do need to be able to come up with variations of those angles. Like, for instance, we had done sine of pi over 3 a second ago. Okay, so we found that sine of pi over 3 was equal to square root of 3 over 2. Okay? You need to know any variation of pi over 3. Like, for instance, 2 pi over 3. Okay? Or 4 pi over 3. Or 5 pi over 3. All those are variations of this angle. And what you can just think of, whenever you have a variation of that angle, if you recognize that kind of the root angle, you could call it, I guess, is, in this case, for both of these, would be pi over 3, then you know that it's going to be square root of 3 over 2. You just don't know exactly what the sign is going to be. But you can use your little chart here. All students take calculus. What this chart tells us is that all, and by all we're talking about sine, cosine, and tangent. Okay? We're not dealing with secant or anything like that, although those are all variations of these trig functions. So all in the first quadrant are positive. In the second quadrant, sine is positive, but both tangent and cosine are negative. Here, tangent's positive, but sine and cosine are negative, and so forth. So for 2 pi over 3, now we do need to know what quadrant that would be in. But 2 pi over 3 is going to be in this second quadrant over here. Okay? So we're talking about this angle. From 0 to here, that angle is 2 pi over 3. So it's in the second quadrant, so sine is positive, so that means that this is just going to be square root of 3 over 2. Okay? Now 4 pi over 3, that is in this third quadrant right here. So you would, only tangent's positive, so that means sine's negative. That would be negative square root of 3 over 2. And if you're not sure, if you're like, wow, how do I know what quadrant it's in? Just kind of use these as a base for you. So this is pi over 2, this is pi. Just think, okay, well, 2 pi over 3. All right, well, that's definitely less than pi, because pi would be 3 pi over 3. And pi over 2, let's think here. Well, let's think here, right? Pi over 2. So let's just compare. If you take the pi out of it, you can think this is like, a half. And this one right here is, if you take the pi out of it, that's like 2/3. Well, 2/3 is more than a half. So, our angle is going to be further than this pi over 2. All right? And 4 pi over 3 is larger than pi, because pi would be 3 pi over 3. But this angle down here is 3 pi over 2. And again, you can kind of compare the 3/2 and 4/3. 4/3 isn't quite as big as 3 over 2. Okay? So, and you could, even if you wanted to, I guess you could make them a common denominator and compare the two angles and see. Good. So, and that applies to anything else. So, if you had sine, or if you had a cosine or tangent that was in a different quadrant, that would apply as well. And the same thing works too if you were dealing with cosecant, because cosecant is just 1 over sine. So then if you think of it as 1 over sine, then you can deal with where sine is, if it's positive or negative. Hopefully that was helpful.